Guys, we're going to start in a minute. We're going to wait for 1 more minute for the attendees to join. We will begin shortly. Okay, in the benefit of time, we will start now. Welcome to the Flash Talks. My name is Fatih Diwan and I will be your host for the talks. Hope you all have been having a good time at this virtual event consisting of some exciting topics. You're going to witness some of the transformation journeys from product to platform, from monoliths to microservices, and the amazing work behind some of our open source contributions. We will have 3 topics in 4 rooms, running parallelly. You can jump to another webinar if the next presentation is in a different room. We will take questions in the end via the Q&A section in the webinar. So let's start with our very first session. Shivakumar Satyamurthy and Premasis Patra will be talking about simplifying product sign up to scale. Guys, over to you now.
Thank you, Swati. Good morning, folks. And welcome you all to the Women in Tech Intuit India event and to the Tech Talks. Myself, Shiva, and I have Premasis with me. And we are going to talk about the transformation that we went through for the product simplification. Before we get into the actual architecture, I want to give a quick overview of what's product sign up and what all products Intuit as a company supports. Now, specific to small business, we have a suite of products. At the core of the ecosystem is the Intuit QuickBooks accounting product. And we have add-ons like Intuit Payroll, where you can pay your employees. We have payments where you can receive payments from your vendors. And then if you're not a small business, but just a one-man army, we have the self-employed product. And if you are an accountant, we have the Intuit Accountant product. And the most recent one being the TradeGecko, which is the QuickBooks Commerce product, right? So as you can see, we have a variety of products, and typically a small business, let's take an example. I, as a customer, I am running a small business and I have a couple of employees in my small business. So I have to pay them, of course, and I would like to track their work, right? So this typically means I need 3 products. One is Intuit QuickBooks to manage my accounting. And second, the Intuit Payroll product for me to pay my employees. And for them to pay, I need to track how much time they have spent for me and for my business, right? That's T-sheets. So typically, a customer can check out these 3 products together. And customer can also buy any of these products individually. So that's what you see on the top right. We have a variety of products. And just like I said earlier, customers can buy any of these individually or together. And the way in which customers can buy these products can be the customers directly coming to our marketing pages and checking out, or it can be agent driven via salesforce.com. It can be via mobile in-app purchases. It could be in products and invitations where, a customer can invite an accountant and henceforth resulting in a sign up. Now, the interesting fact here is any of these products, small business products, sign up or checkout happens via single platform capability. And on average, we provision almost close to 4 million plus signups in a year, and it ranges from across these products. So with that context, let me move on to the architecture. So what you see on the left is the older architecture, and what you see on the right is the newer architecture. Let's spend a minute on the older architecture. So as you can see here, this entire architecture is a completely orchestrated one. For a typical customer sign up to be successful, the interactions that we see on the left, all of them have to be successful for a customer to check out the product. Now, what this means is there is at a minimum of 40 plus network calls, 700 plus database transactions, and this entire API itself spanning over 13 plus seconds. Now, this for a customer to just sign up for a product. And if it's on average day, we also see that if any of the systems is momentarily down or is blipping, then there are these what we call as failed customer interactions or checkout failures. And on average, we used to see 70 failures a day. Now, that was the architecture. As you can see here, this is a completely orchestrated and a synchronous architecture. The problems of this are pretty evident here. And that's what now we can see on the right. You can follow the numbers 1, 2, and 3, and 4, right? So that is the reactive architecture on the right for you guys. It's pretty simple. At the middle of it is the distributed microservice on Spring Boot, built on Docker and running on Kubernetes. The responsibility of this company service is to create the bare minimum Intuit entities required for this checkout. And post that, it publishes a message onto the Intuit event bus. In our case, it is Kafka as a messaging system. So a message is dropped onto the event bus. Now, all the consumers that you see below the Kafka bus, numbered by 4, are all listening to these messages, and then they inspect the message. Hey, should I be doing something about this message? If the checkout involves that product, then the particular consumer picks up the message and then sets up the product. So as you can see here, what used to be an orchestrated synchronous architecture on the left, completely on monolith, is now liberated into a distributed modern tech stack microservice architecture and a reactive one. Now, the benefit of it is this entire transformation resulted in a 40 plus HTTP calls, resulting to just 6 odd HTTP calls, 700 plus database transactions to 13 odd, and the API, the TP99, the performance of the API itself reduced from 13 plus seconds to a sub 1 second. And because we reduce the synchronous dependency on the systems, we also reduce the failures to just 4 failures per day, which is like 0.04% of failed customer interaction. What this also means is, we also had close to 4 million plus savings because of the revenue we make across these signups. Now, there is a saying that simple is not equal to easy, and we all engineers know about it. Even though the reactive architecture looks pretty easy and simple, it's not really the case. And that's what Premasis is going to talk about, the challenges and the learnings we had in this transformation.
Yeah, thanks, Siva, for explaining the use case and talking about the journey on how did we bring the transformational changes. Let me talk a bit about the challenges that we faced across the journey and how did we solve it and what are our learnings, right? So typically, if we are building any of the web application, the first critical challenge is resiliency. So we have to always take the assumption that failures are bound to happen across the systems, right? And everything will eventually fail at certain time. And specifically for our use case, when we are saying that, okay, we just decomposed a system to a distributed architecture using the reactive patterns, the failures are bound to happen. And these systems are typically inherently chaotic, right? Because of the way the components are there. There is a Kafka, there is a reactive pattern and all that. So what we took care is, first thing is the failure, right? What all failures we can have. And the next thing is how is our ability to auto recover to ensure that, okay, there is no customer impact if anything fails in the background. So in order to do that, what we did is we just wrote a FMEA, which is failure mode effect analysis doc. And we have taken every assumption. So that say, hey, can Kafka go down? And what will happen if Kafka go down? And let's say Kafka is up and consumers, there is a delay in consuming the message. Or it is like consumers just consume the messages and the JVM crashed. Scenarios like that, right? And we try to establish a severity of the individual use cases and how to solve that in order to ensure that can we have a uninterrupted customer experience, or some use cases we had to introduce a compensated experience. Uh, so we build out the solution based on that. And now the next challenge was on how to verify or simulate these failures, right? So in order to do that, what we did is we used a framework called Chaos Monkey, which is a open source framework, and that gives us kind of a emulator framework, and which is able to kind of introduce the latency, introduce the delays, introduce the failures, and all that, and we ensure that, okay, even though we are ensuring the failures at the runtime or the production, the customer have no issues and the end result is successful. So with that, we leveraged, solved the resiliency with the testing as well as the auto recovery patterns. So the next challenge for us was the eventual consistency, right? So as Siva explaining, typically for a application like QBO, the customers can come with a suite of products. For example, they can choose to QBO, payments, payroll, and all that. And the experience was built upon like whenever the existing, which was the monolithic application, the experience was built upon like whenever the customer signs up and lands into the product, he says that, okay, everything is set up and I am ready to use that. With the reactive architecture, as we said that, okay, with the bare minimum changes, we are letting the customer go into the home page, but while the other setup is running in the background. So there can be some cases where there is a change in experience. Because as you know, as per the CAP theorem, we can achieve two. So we achieve the availability and the partition tolerance, but not the consistency. But we definitely cannot afford to change the customer experience suddenly because of the architecture, because it will cause a dramatic change on how they landed. So in order to solve that, what we did is we have introduced a pattern called zero state product setup, which was just injected on the on-demand basis to ensure that, okay, whenever the customer needs something, everything is all set up. And this was a very unique pattern. In fact, we patented this idea on how to solve that. And also we have something called a FTU, which is a first time user experience, that also helped us a bit. And by this, even though in a eventual consistent system, we have achieved to get a certain level of consistency across the system, and the experience was very smooth for the customer. Now, the next challenge for us was the idempotency, right? Typically, in the reactive patterns, when there is a event bus introduced, event bus is in place, and there are offerings that listen to them and they react to that. And the reactive systems always guarantee that there can be at least once delivery, but does not guarantee that there will be not more than one delivery, right? And it can be multiple. Which means that whoever are listening to the Kafka bus, event bus, and they are participating and trying to process those requests, they can receive duplicate messages. And they can receive the messages duplicately immediately or after a minute or so or anything like that. And if you have like your application is like a clustered architecture and you have multiple JVMs, then also
just a time check. Sorry.
Sure. Thank you. Thanks. So in that system also, the systems can receive the multiple messages that, okay, there are multiple JVMs and all they're trying to receive the same messages, right? So how do we solve that? The challenge most was all for the distributed pattern, where we are having that multiple JVMs and we are saying that, okay, hey, all are receiving the same messages, and there is a potential chance of concurrency, where all the JVMs are listening to the message. They feel that, okay, this is the first time we're listening this message and we're trying to process that. And how do we solve it? Since it is a distributed architecture, we introduced a distributed locking and we leveraged Redis for that, so that that helped for the concurrency. And with that, we got the benefit that, okay, even the multiple JVMs across the clusters are listening the same message, they're able to process it uniquely. And they're waiting for one consumer, right? And next thing was for each consumer side, we had introduced a specific idempotency check, so that even though, let's say I just received the message now, and after 1 hour, I'm receiving another message, I should be ensuring that, okay, hey, I am always setting up one. So there is no loss of data or no change of the state of the data. So these were the very three critical challenges every application face in any of the distributed systems. And that's what our learnings and how do we solve that. With that, we am wrapping up and we are open for any Q&A.
So in the interest of time, we will be taking the questions offline. The audience is requested to reach out to our experience zones from the homepage, and we'll be happy to answer any of the questions. Thank you, Premasis and Shiva, for sharing this journey with us, which was very insightful. Now we move on to the next session. Dilee Alakkat will be talking about transforming enterprise ERP to SaaS. Dilee, over to you.
Hello, everyone. My name is Dilee Alakkat, and I'm going to talk about transformation of our ERP to SaaS today. Okay, so ERP is the application enterprises typically use for its key business operations, and traditionally SaaS and Oracle has been the market leaders in the ERP space. Intuit's current ERP, Oracle eBusiness Suite, was implemented in the year 2003 and is used for some of our key business processes like finance management, procurement, order management, etc. So when we implemented our ERP in 2003, we were a 1.65 billion companies, and today we are 6.8 billion plus company. And like over the years, we have implemented many off-the-shelf as well as in-house built applications in our ERP space, which made our ERP space very fragmented. So like the challenge with this fragmented systems is that, like, there are duplicate data entries, and like, like it's hard to derive insights from this duplicate data, and like users struggle to use, and also is operationally challenging to maintain as well. And so what's the transformation we are doing? So we are moving from our like this monolithic ERP application, which is Oracle application suite, and all these fragmented systems we have in this space, to a more federated and like loosely coupled ERP platform with some of the best in class SaaS applications. So to talk a little more about this, like we are moving bulk of the ERP functionality to SaaS, and like we are implementing the applications like Coupa, Aravo, Blackline, etc. In towards this effort. So like our current ERP, Oracle eBusiness Suite, will be used only for like accounting and reporting purposes, and like users will be interacting like only with the SaaS applications, which I talked about. So that's the key transformation we are doing, and like this is in line with what Gartner calls the postmodern ERP strategy, or like hybrid ERP strategy. And the key business benefit of doing this is that like we will be leveraging, we'll be able to leverage all the innovations this SaaS applications bring in at a very low cost, because the SaaS applications typically operate in a subscription based model. Now, how did we start this journey? Like we moved our current ERP from Oracle, which is Oracle eBusiness Suite, from Oracle Data Center to AWS. So this not just allowed us to like lower the cost of infra, as well, it also allowed us to integrate easily with other applications, which is in the Intuit owns, which is already in AWS, as well as also allowed us to integrate with the SaaS applications easily. Now, the next step in our journey was like to move from file-based integrations, like which is typical for the ERPs being a backend system, and we moved towards a more real-time and event-driven integration. This was critical because like we were having multiple SaaS applications, and all of this needs to be integrated into our system in real time for us to leverage the insights from these SaaS applications. And like before this journey, we didn't have a middleware solution, and like we implemented a new integration platform using microservices to enable our journey to SaaS, like which was again built in-house, and is microservices based and is loosely coupled, and enables easy integration with all these SaaS applications. And like one other like time-saving effort in this journey was like the test automation we implemented using Axle Q, like which saved us tons of time, because this automates the testing across all the SaaS applications. So this is how our current state and future state look like as you in the source to reporting space. And as you can see, we have over 15 plus applications in our current state. And in the future state, we are using Aravo, which is a SaaS application for third-party risk assessment and supplier onboarding. And like in the sourcing and procurement process, we are implementing Coupa again, like which is a leader in this business spend management softwares in the SaaS side. And other backend process like payment and accounting will remain in Oracle eBusiness Suite. And we are again for accounting and period close and the reconciliation process, we are implementing another a SaaS application called Blackline. And our reporting and spend analytics will be done on Click and GEP. So now to enable this SaaS integration, like this is the integration platform we built in-house. And like one of the key feature of this is that like this is a very scalable model which we can use for future SaaS applications integration as well. So what we did was like the key ERP functionality was broken down into microservices, and we implemented these services as REST APIs in a publisher subscriber model using Kafka as our messaging platform. And so these integrations are triggered based on the business events from either the Oracle eBusiness Suite or the SaaS applications like Coupa and Aravo. And we also have integrations built with EDW, which is our data warehousing platform, and all the reporting is done out of EDW using Click and GP. We on the operational excellence side, we also have like dashboards built on Wavefront and Splunk, which is used for observability. And coming to some of the challenges and learnings we would like to share with you, as we all know, like, the transforming from like these fragmented systems to like few systems in the SaaS is not an easy, especially in the ERP space. So apart from the challenge, like, of migrating whole of our data from these applications to and consolidating them, like some of the tech challenges like we faced are like, deciding between build versus buying integration middleware. So like us, we did some proof of concept, like with some vendor provided middleware solutions, and our learning was like that these solutions are not typically flexible for our custom business needs. That's where our decision was to go with in-house built integration middleware. And another tech challenge which we faced was to enable the event-driven integration from Oracle eBusiness Suite. Like this was, so typically this is done using ERP adapters or like the integration repository which Oracle eBusiness Suite provides. But like in our past experience, like we have encountered challenges again with our custom business needs. That's where like we went with those Spring Boot-based services which are triggered from the business events in Oracle eBusiness Suite for this integration. Also, another challenge with this, with the integration of SaaS was that like we have multiple touch points, like where the integration can fail. And so we built a global error and retry handler to handle the exceptions across our integration integration layer. And like we have adequate logging and monitoring built as well. So like ERP being a critical application, like where idempotency is critical. How are we solving this is like by using a distributed locking mechanism, using shared lock, and like we are having idempotency keys and like checks at every point to ensure, like, if same operation is retried multiple times, like we get the same result. One other challenge like we faced was to ensure data integrity across the SaaS applications, and we have multiple recon reports built, like which are daily as well as monthly, to ensure data integrity. So with this, like we have not just enabled ERP platform, which is very user friendly and like users love to use. We have also enabled that, like we have real time integration between the applications, which enable business to leverage in context and real time insights from across the applications for key business decisions. So this was a key step in making our enterprise applications more data driven and enabling the critical business decision making. Yeah, thank you, and happy to take any questions.
Thank you so much, Dilee. I have a question for you. So, if you had to choose between all the challengings and learnings that you talked to us about, what would you say was the biggest challenge in this journey of yours?
So the biggest challenge was like ensuring the data consistency across all the applications. Like as you can see, like we have SaaS applications as well as the ERP application, which is in our AWS data center. So like the challenge was to ensure the data consistency across all the applications. And how we are doing is like, apart from making sure like the data is integrated real time across all these applications, like we do have multiple recon reports built as well, right? Like to give us, like if at any point like if the data is not in sync, like we have multiple alerts, as well as like we can see them in the dashboards, as well as and to take quick action. This there is a lot of alerts built on this. Like we have email alert, we have integrations with Slack for Slack alerts, like to admin, to the business users. So like there are lots of checks in place to ensure data consistency, which is very, very critical for like the to ensure the data reporting is correct and consistent across the systems.
Yes, I agree with you. Okay,
Yeah,
thank you
thank you.
so much, Dilee. That was great. If you had to give some advice to someone who's starting a similar journey, what would you say are the prerequisites for starting a project like that?
Sorry, could you repeat the question once again?
What would your advice be to someone starting a similar journey, like transforming
Yeah.
enterprise ERP to SaaS?
Okay, so one advice I would give is like is planning out this journey upfront, and like ensuring how you want your data to look like in the target system, like target system where you are envisioning. And so like we started so sharing some learnings from our journey. Like so we spent almost 3 months like only planning like the data mapping out the data, like how we are mapping our current data to the target data. And like one of the advantage we had with this was like when we actually started the design and like development journey, our data mapping was already run. Like we knew how like we are going to map the data from the source from the existing systems to the new systems, right? Like so that's one advice I would say, like plan in the planning phase itself, like plan how you want your data to look like in the target systems and how you're going to map it.
Thank you so much, Chili. That was very informative and very insightful. So
Thank you.
now we move on to our next presentation, which is Bharath Bhushan, who will be talking about migration of legacy Oracle-JCA adapter to custom-built microservice implementation. Over to you, Bharath.
Hey, hi, thank you, Swati, and hi and good afternoon to all of you guys. So, we'll just talk about our journey and some of the activities that we have performed during the migration of the legacy Oracle-JCA adapter to a custom built service, which is which is actually a microservice implementation. So, just to give a quick background about what exactly we do at Intuit, especially this particular application, and then where exactly this whole fits in. So, as many of you might already know, so Intuit has a variety of products that we provide, right? And QuickBooks Online or QuickBooks Desktop is one of the key products that Intuit has. So, like the name itself suggests, like QuickBooks Online and QuickBooks Desktop, these are for two different platforms altogether. Which is on a cloud-based SaaS platform, which is the online version, and then the desktop standalone application, which has been which was a pioneer product in the QuickBooks lifecycle. So in each of these two products, though some of these features, many of the features are common and are used for the same purpose, but the way you maintain the subscription and entitlement of these products and then the licensing, so it all depends and it's all different in the platforms level. So that's the main reason why we have two separate billing platform for the I'll just dig in deeper on what exactly the billing platform means. But so that is the main reason why we have a two different platforms, which is also called as OBIL or the online billing platform, and DBIL, which is also called the desktop billing platform. So in both these platforms, we have an application or a product which is from the Oracle, which is a proprietary licensed product called the Oracle BRM, which is the billing and revenue management, which is the core billing engine in these two platforms. When I say the billing engine, so some of the activities or some of the operations that this product does is to maintain and manage the complete subscription lifecycle of any customer. That is, say if you have a subscription with QuickBooks Online, so your customers details will be available, will have to be present in this BRM. And some of the details, like you sign up for a particular product feature, it could, or a particular recurring billing cycle, like it would be a monthly cycle or an annual cycle, and the different SKU that you can sign up for. So all these details are maintained at BRM. So as you can see, the features like doing a recurring billing of any customer, so of a subscription, or issuing any refunds or adjustments, all these operations are available. So like any other application, so now in order to do a CRUD operation, you need to have an interface for this. So at Intuit, we have built a very strong customized solution over this BRM. So BRM itself is like a platform where we have built a lot of customized solution to meet our business needs. And the interface to this BRM product is and to this BRM is another product called the Oracle-JCA, which comes as part of the BRM suite. So this provides which is a SOAP service, and it will, as the name itself suggests, it provides a SOAP interface to perform any of the CRUD operations. So it could be creating the subscription of any customer and then doing any update operation. So all these things are available by Oracle-JCA. So some of the limitations that I wanted to discuss with you guys about this JCA is, I mean, it obviously is a very nice product and it's been used by many of the telco customers. So, like how we've been using BRM, so there is a lot of other telco customers which use BRM in their business needs, in their business implementation as well. So some of the limitations that we faced at Intuit was uh, the service itself does not meet the compliance of Intuit service or the architectural standard. So at Intuit, any of the service that we have are either is follow the adhere to the REST principles, which is a REST service, or it's exposed as a GraphQL API. Or in the recent past, we've also started hosting many services which follow the GPRC protocol, which is the Google remote procedure call. Now, since this being a SOAP interface, so there are quite a few limitations when it comes to clients accessing it. So that is the main reason why the direction is to proceed to one of these three service architecture. And the next major limitation was JCA comes with a heavy tech stack. So Oracle provides a compatibility matrix and also certifies Oracle-JCA to only run on WebLogic server or on OFM, that is Oracle Fusion Middleware, or AIA. and all of these things comes with its own baggage of additional licensing or additional installation of the applications, and it also all comes with additional maintenance and support capabilities. So that is one of the things. And during any issues, or if you want to assess anything, so the major issues that we generally face is with in terms of operational complications, may it be logging, or to dig into more details about what exactly has happened, or configuring or adding a new like we use at Intuit, we use things like app dynamics and wavefront to monitor the behavior of an application, and to basically proactively catch any issue that could happen, right? So all these things come as a challenge when it comes with a ready-made tech stack, and where we do not have much of the flexibility to make any modifications. And at Intuit again, so we have a private API gateway called the Intuit API gateway, where all our services at Intuit is hosted behind this gateway. And this gateway itself provides a lot of benefits, like routing the request based on the request type, or allowing different levels of security or authentication based on the API type itself. So I'll dig in more details about what different APIs are available in different protocols. So that was also and API gateway only supports the three service standard that I talked about, and SOAP isn't one of them. And some of the other major challenge when it comes to maintenance is, since Oracle is a proprietary product, it comes with a maintenance lifecycle, and there are patch sets which has to be regularly upgraded. So whenever these comes in as a ask for us to do an upgrade, the JCA is also supposed to be upgraded, and there is a lot of cases where the clients are also impacted, because they will have to adhere to our maintenance lifecycle or the upgrade lifecycle and then make the changes. And the next last but not the least is like wait about the tech debts. So if there's any tech debt about like the Java upgrade or a security defect, so it all goes to, we have to make a request to Oracle, and Oracle has to prioritize it and release a patch, and then we make the corresponding changes at our end. So in order to remediate all of these, and to basically inherit speed into our day-to-day activities, and also to have a seamless experience to our clients or any external um teams within the internal teams within the Intuit. So we thought about replacing this whole JCA architecture, or the JCA application, into a custom built service which adheres to the Intuit standard. And that's how we developed this particular microservice, which is a Spring Boot application, which is exposed as a REST service. So by doing this, what we were able to do is, like, there are about close to 43 to 47 APIs where we've done the logical grouping based on the functional needs. It could be accounting, it could be offers, or it could be subscription. So based on these things, we have done a functional grouping, and all these APIs are now categorized as APIs, or as private APIs, public APIs, or sensitive APIs. So public APIs could be something like a catalog information, like anyone who lands into the marketing page would need to see what are the different offerings that Intuit provides, right, in QuickBooks. So these are all called the public APIs, and then there are private APIs which are specific to any customer's data, and then there is sensitive information where there are more sensitive information like credit card information or the payment address. So we categorize the APIs based on this, and we have assigned we do the authentication, or we have the security measures taken based on the API type, and all of these are now taken care by a mere configuration change. So all you have to do is configure this particular API is either public or private or sensitive, and everything is taken care. And also A&A, so which is called the authentication authorization. So we both authenticate any request and also check if that particular requester is authorized to access this particular data. So all these kind of flexibility is achieved when we develop this particular API. And one of the major changes that we brought in was we developed a whole new custom JC adapter. So by custom JC adapter, so what we mean is the Oracle JC adapter also has to be installed at the client side, even though service is owned at the PRM side. So a client residing in a different platform, it could be in cloud, or it could be in a native on-prem hosting. So there has to be a direct connectivity from the client to the service on a non-standard port. It could be a non-standard HTTP port, right? And we didn't want that to happen. We wanted to have a proper modularization. So that's the main reason why we developed a whole new custom JCA adapter, where the whole communication is now over HTTP client instead of the TCP HTTP protocol, instead of the whole TCP protocol which was in the underlying JC adapter. So this were the major things that we did, and by doing this, and during this development lifecycle, we also created about 3 to 4 libraries which are now used as frameworks, and there is a scope to make these libraries available in the open source so that many other implementation can leverage on this. So some of the benefits that we've achieved by doing this is single point onboarding. So all the requests are now behind the, I mean, all the onboarding is now to the gateway, and any client within Intuit can now seamlessly onboard by mere clicking on the onboarding, and then by getting the specs ready, right? And the major win is again on the optimized operational and maintenance cost, and also on the operational excellence point of view. So since there is no additional tech stack that we had to bring in, and everything is built on a lightweight Spring Boot application running on its own inbuilt Tomcat container, we don't really need to have any expertise who on the WebLogic server, or get into the licensing cost of deploying WebLogic server or Oracle-JCA. And now we have a flexibility scaling, unlike JCA where you need to scale up the whole infrastructure. Now we can only scale up a particular API group based on the traffic pattern. Like if we decide there's a particular API where there is more traffic, we can only scale up that particular API by doing horizontal scaling or vertical scaling based on the need. And like I mentioned, there is operational excellence. So like we have at Intuit, we use App Dynamics, Splunk, and Wavefront to monitor the application's performance, and also set up the alerts to proactively catch any issue that could occur and take proactive measures. If there is more load, we take a look at it and set up, and then automatically increase the load, or increase the infrastructure, the footprint of the old service, so that we can handle more load. And like we mentioned, so the frameworks that we have developed, now it's in the pipeline to be open source at Intuit, so that now we this whole framework is open to a wider community, and many people can now benefit from this. And also I mean, even we can, I mean, it just opens up the whole flexibility of open source, right? So these are some of the activities that we performed, and by doing this, out of I think close to 20 or 25 implementations across the industry, we were the first ones to actually move to a REST based application, to a REST based service infrastructure, or the contract for BRM, and also host the whole BRM into AWS as and we have been running it in the production. So this is so I'll probably close at this, and I'll open up to any questions.
Okay. Thank you so much, Bharat. I have a question for you. So thank you so much for sharing such an informative project with us. What do you think was your biggest learning in your whole journey? Like, just share with us, you would like to know.
Yeah. So this was quite a bold move, right? So because Oracle BRM product itself is close to what, 12, 13 years old, and majority of the telecom customers have been using this. And we were breaking the very I mean, not exactly breaking, but we took an initiative to actually change the very first interface that people have been living with so many years. And by doing this, like we had to bring in the confidence of so many people. Like we had to and we had to be thorough, right? We couldn't, because Obil or Deeble desktop platforms, these are very critical at Intuit. So any downtime or any issue, be it functional or operational, can directly have a customer impact, and can directly, I mean, when I say customer impact, it could not just be the user experience in the UI, but it could be a monetary impact. Like we deal with money, right? So what this was one of the major thing, and by so we had to really be sure that we are very thorough by doing this. So what we did was we had like a major regression suite that is running, and a lot of feature based testing. And now we have a very good uh, test bed set up, so that any new features can be taken care. So this whole learning is something that we have taken and implemented in the other implementations as well, and it's been working out well.
Thank you. Thank you so much, Bharat. This was very informative. We will now break for lunch. And don't forget, the last leg of the treasure hunt is going to start now. Post lunch, we will have a mindfulness session by Shinomics, so don't miss it. And I'd like to remind the audience that during our breaks, our networking booths with Intuit Circles, Talent Acquisition, Intuit CSR, and Innovation Catalyst teams will be available for conversation. Do visit our experience zone from the homepage. Thank you so much for joining us. Thanks all of you. Bye.